Hey guys, welcome. Now, the reason we have this video is because I want to teach you how to prove a proposition using the inference rules that we have. The inference rules will be pasted in this video on the left side or the right side, depends. Now, let's try to jump into a problem that we want to solve. Now let's try to solve this one. Now, in a problem like this one, you need to realize that what you want to prove is only the right side. Everything on the left of this symbol are given, and the givens are separated by comma if you have more than one given. Now, a proof begins with a line, so let's begin with a line here. And each proof line are numbered. Let's begin with number 1. Usually we begin with a given, so we have the first given here. Just write it here. This is. And we have a second given, separated by this comma. Now, for the reason, we write given, and we write given. Now, number 3 is, because this is the first time that we're trying to prove something, number 3 is the hardest. What do we write in number 3? What should be in number 3? And in order for you to proceed, you need to plan. It's not easy on the first time. It becomes easier as you go on. Now notice here that we have an implication on the first line. And the antecedent here looks exactly like 2, only that the Q is missing. If we can come up with a way so that we have this one, then by modus ponens we can have Q and R, and by Q and R we can do something with it so that the Q is retained. So let's try. By virtue of addition, you can check the inference rules by virtue of addition. If we are given a propositional variable, then we are free to add a different variable provided that it's a disjunction. So for me, in order for me to use it and in order for it to be convenient to me, I'm going to use Q, so that if I do a simplification of this addition of 2, add, I'm going to add the variable Q instead. And now that I did that, notice that number 3 looks exactly like the antecedent of number 1. And if we can do that, then we can have a modus ponens of 1 and 3. Modus ponens of 1 and 3 allows us to come up with a consequent of 1, the Q or R. And notice that it's almost the same as what we want to prove, Q, only that the R is there. But if we're going to check our inference rules, we're going to find out there's an inference rule called simplification that allows a variable to be removed if it's in a conjunction with another. And exactly the variable is in the right of the Q, and we want the Q to remain, so we want to remove the R. So we're going to do a simplification of number 4. And after simplification, what remains is a Q. And the Q is what we really want to come up with. So since we come up with a Q, then the proof is done. And we can end with a therefore, restate what we have on top. Q or R, P entails Q. You read this as entails. And now, voila, your original proposition is proved.